Science defines matter as anything that has mass and takes up space. Everything in the known universe, with the exception of energy, is defined as matter. You, your chair, your shoes, your street, your breakfast, you get the idea. It's all matter. Matter exists in four main states: liquid, solid, gas, and plasma. In many cases, depending on its makeup, matter's state can be changed by either adding or removing heat. For example, water becomes steam if it is heated, and ice if it is frozen. Solids have a definitive shape of their own, while liquids don't. The composition of plasma and gas are very similar. Neither has a definite shape or volume. The difference between them is that plasma has a charge. Gas is neutral and has no charge. All matter is composed of elements, which in turn are composed of atoms. Elements are pure substances composed entirely of the same kind of atom. For example, in its elemental form, copper contains only copper atoms, carbon only carbon atoms, helium only helium atoms, and so on throughout the periodic table. The word atom means indivisible in Greek, so named because ancient Greeks believed the atom to be the smallest particle of matter left after it couldn't be divided any further. Of course, we now know that to be untrue, but the name stuck. Currently, we understand an atom to be composed of three particles: protons, neutrons, and electrons. Protons carry a positive charge, electrons a negative charge, and neutrons are neutral, meaning they carry no net charge. At the center of every atom is a dense nucleus composed of protons and neutrons, orbited in a cloud of mostly empty space by much smaller electrons. Electrons are held in their orbit by the electrostatic force resulting from the attraction to the opposite charge of the nucleus's protons. Electrons can escape their orbit, but only if an external energy source is applied. The closer an electron orbits to a nucleus, the greater the force. This means an atom's innermost orbits, called shells, tend to be more populated by electrons, while its outermost shells are not. Often, atoms will either share or transfer electrons, forming molecular bonds. For example, a molecule of water is H2O, or two hydrogen atoms bonded to one oxygen atom. These bonds can be formed in one of four ways: ionic, covalent, hydrogen, and van der Waals. An ionic bond between atoms is formed by the attraction of oppositely charged ions. A covalent bond is formed when two atoms share one electron. Hydrogen bonds are formed by the attraction between a positive end of a water molecule and the negative end of another molecule. Van der Waals forces include the electrostatic forces that attract neutral molecules to one another. Being chemical in nature, ionic and covalent bonds are stronger than the attractive forces found in hydrogen and van der Waals bonds. Subatomic particles are believed to have first formed in the few seconds immediately following the Big Bang, when the temperature had cooled enough to keep them from blasting back apart, but before things have expanded too far for them to find one another. It took another 380,000 years or so for the universe to cool down enough to allow electrons to become trapped in orbits around nuclei and form the first atoms. These first atoms were helium and hydrogen, which remain by far the most abundant elements in the universe today. Heavier atoms, such as carbon, oxygen, and iron, are produced during nuclear reactions inside of distant stars. These atoms are blasted throughout the universe in stellar explosions called supernovae. Eventually, they find their way to distant places like Earth, where they make up everything we know, including us.